Improper integrals is not a new integration technique. Okay, there's nothing new like UDV, all that integration by parts stuff. What it is it's understanding the infinite a little better, okay, and being able to calculate the area under a curve for functions that continue on to infinity. Okay, so you're going to see something like this.
That from 1 to infinity?
Yeah, that's an improper integral because this right there.
How do you evaluate that?
Okay, that's the question.
I just put it at infinity.
Right, so what you have to be aware of is something in calculus called convergence and divergence. Okay, so convergence in mathematics, at its most basic, is do you get a numeric answer? Do you get a number? Okay. And this will continue into series and sequences. These are big ideas. Divergence, where do you think it heads? You get it? It's infinite. Something, it just goes, diverges, right? Kind of like that Revenge of the Teens book series. Divergence. It just goes. Never stops.
I got the joke. That's really funny.
I call those movies Revenge of the Teens. Because they think the teenagers need to save the world. Hunger Games, Revenge of the Teens.
Two different books, but okay.
Yes, but they're the same.
It's the adult youth or young adult novel
Right, exactly.
series.
Yeah.
Revenge of the Teens.
Okay, so if you draw this graph out,
Yeah.
most people's gut reaction is to say the area under this curve is infinite because it's ever increasing. You see this slice here is always there, right? Because we never hit 0 with the function. So the gut reaction is usually, well, that's infinite area. Okay, no, not necessarily. It could diverge. It could give us a number. And the convergence, it's a number that's like a top end. Like it will never cross this number. Okay, so this really is a number that's never crossed.
What do you mean? It's infinite. It's going to cross it.
Okay. Like you're adding so little value, like out here, let's say you go out to 10 million, right? You're adding so little area at that moment that it still doesn't bump you above some top ceiling. Okay, does that make sense? It's never going to get above a certain number because those values you're adding are so stinking
So
small.
like you get so many decimals that it just doesn't matter anymore.
Like you're adding like 0.000000000000001 units.
Yeah, you add enough of those and then bam.
Yeah, but if you have a million zeros and then a 1, it's really hard to add those up to cross some number. Okay, anyways. Okay, so that's what we're up against. All right, it's a big idea. The question is, how do I solve those?
That's what we'll look at.
Okay. Let me get you this slide. Let's just work with that one. Okay. Your first step is to take that out of the integral limits. Because that is not a proper mathematical statement. It's improper. Why do we call them improper integrals, right? Okay, so we use a limit. And we call it as r approaches infinity. And we go from 1 to r. Okay. So you take the infinite out of the integral limits and put it as a limit.
So the limit of an integral?
Yeah. So we have derivatives and integrals and limits and integrals. It's like the calculus, like it's just such a beautiful, wholesome topic.
Beautiful.
I think it's really pretty and elegant.
It's very certain.
You'll learn. Trust me. You will not always hate calculus. Some of you already like it. Okay. Now we just do this as a regular integral. Okay. Always keep this with you. What's the antiderivative?
Natural log A.
Okay. Evaluate from 1 to r. And we go there.
You did the absolute value of natural log X on this one? Is it E, I remember stuff.
Okay. So the limit as r approaches infinity. With natural log r minus natural log 1, right? Evaluated the integral. Now you're evaluating a limit. So, what is natural log 1? 0.
Oh!
Right.
He's learning.
Natural log infinity. Where does natural log go as it
0.
tends toward the infinite?
0.
No, that's not true.
Wait, no, as X approaches infinity, Y approaches 0. That's the option.
No, that's for 1 over x.
Oh, I don't know.
Oh.
We're talking natural log, because that's how we
So it's-
calculate the area under that curve.
Infinity then?
Yeah, because natural log's graph looks like this.
Yeah.
So this is infinity. Okay, so we would say the integral from 1 to infinity of 1 over x dx diverges.
So we're
It's such a rebel.
we're never gonna say like give a number. We're just gonna say diverges or converges.
Well,
You are going to get to that situation in series and sequences.
Okay.
Here we're looking for diverges or a number. Okay, so it's a rebel. Diverges. You're part of the Rebel Alliance of the Traitor. Take her away.
On down there, Star Wars.
Classic. Okay. Let's try one like
What you're talking about.
something that we find good. Show that. Integral from 2 to infinity of 1 over x cubed converges.
You just went with the joke.
And compute its value. Okay, so booyah, they gave you the answer. It converges. You just have to find the number.
Oh, you can't do that.
Hey, Hunter, what's the first step?
Limit. Make the limit.
Right, is the limit, okay. What's next, Montaigne?
The limit as our approaches infinity with the period evaluated from 2 to r.
Okay, with the thing integrated.
Yeah, I don't know. I was trying to figure that out. Is it natural log 3x? I feel like it's so wrong.
No.
It is.
Yeah.
You killed puppies.
That.
It's x cubed, so it's not natural log.
X to
The feeling serve you well.
X
It's
to negative
we don't
3.
need a super
a
big.
power rule.
It's 1 over x
It's
squared.
power
It's 1 over x
That's
squared.
x to the
Yeah.
negative 3, Cole.
Yeah. 1 over x. I'm stupid.
Add 1,
Yeah.
x to the negative 2,
Yeah.
divide by -2,
Nice.
right?
So,
That's
oh yeah.
pretty sloppy. Right? Correct me if I'm wrong, I haven't been sleeping lately.
What is
Very good
this
if you
sleep
do
you speak of?
I would like to know, honestly, I really would. Okay, next. Isaac?
Why do you divide by 2?
I'll answer that here soon.
Oh,
What do I do with this, Isaac? Evaluate.
How is it evaluated?
Evaluate that function.
I'm so
Okay.
confused. Why do you
Isaac, you
divide by
good, man?
-2?
Efrain, you had a question.
Why do you divide by -2?
It's an integral and a derivative. Add one, divide by the new exponent,
Oh,
right?
yeah.
All right. This gives us positive 8 on the bottom. What's that?
0.
Yeah, 1 over infinity is 0. There is,
I almost said negative infinity when I felt negative.
so you have a function that looks like this from 2 to infinity. That area is a measly 1/8 at its most. That would be the top end ceiling that's never crossed. Okay. The numbers continue, like the farther out you go, the closer and closer you'll get to 1/8. It just will never, ever cross.
Wait a second. So we did differently.
Okay. 1 over x diverges. Anybody take a stab at 1 over x squared?
No.
Diverges or converges? It's right in the middle of the two.
It converges.
Neither.
No, wouldn't it diverge because the integral ends up being 1 over x?
1 over infinity is
0.
converges. There's your kicker. 1 over x, 1 over x squared, there's your separation.
Oh.
Yeah. So 1 over x squared and everything else converges. We'll be more specific there with series and sequences on that. Specific difference. But. Okay.
What?
Check, see what I wanted to do here.
That's all I heard.
Oh, this is a good one, and we have time, so we're gonna do it.
I didn't need to confuse them.
A good one, that's what I said.
Freaking hurt.
Does that mean tricky?
Probably. Yes.
This time they had this like super fine piece of metal that was just stacked in there.
But why
So
though?
they like cleaned
No,
out the
X.
pressure washer after you got.
What are you doing?
I'm really trying my hardest to be here. So I have to entertain you guys.
Have you gotten the pressure washer? Yeah.
I'm gonna quit teaching and become a stand-up comedian. I'm gonna make millions.
You become unemployed within
I probably would. No, we don't want you. Why not? I'm funny.
Yeah, in a
I
math
have a bunch of math jokes.
Oh,
That's
You get that. Because most of the people that take this course
Forget about
Forget
it.
it too.
Yeah.
Oh my.
All right, first step.
Women. You like the pressure washer?
Okay.
Not in your ears.
No, not your
Yeah.
ears. You just ignore the pressure water.
And
No,
then
the
just
integral.
like everywhere else.
The
Make sure it's
integral.
straight.
Frank,
Yeah.
what's the antiderivative of x e to the negative x?
So what do you mean?
Ultraviolet super voodoo.
It is an integration by parts
Yeah.
problem.
So your eggs.
Welcome to calculus.
U
is
UV.
U is X. No, U is.
Hey, use X.
Okay.
Use X.
U is
Yeah.
No, what's the?
Yes. V is whatever U isn't.
That sounded
Why
like.
don't you just be quiet?
Well, it's not.
That's what you isn't.
Yeah.
Speak that language here.
I was using, no, that's proper grammar, because we're talking about ultraviolet super voodoo.
You've never
And he
had
asked
proper-
what
It's
U is.
singular, right? Or plural? I don't know.
Is it in the files?
I learned my English.
Please don't make me go to English yet.
Here's a fast fact. My English AP scores were just as high as my math AP scores.
Hooray.
My English is terrible.
Don't think she's too impressed.
I'm
Both bad.
sorry. I'm sorry, but my English AP makes me want to hurt someone.
I think I'm gonna do good this year.
In English?
Yeah.
Probably better than last year.
Well, because it's argumentative now.
Horrible.
Better than last year. I got one last year.
I got a 2.
Maybe
It's not
negative.
even my native language.
Negative.
It's not even my
The
native
negative.
language. Get right. E to the negative x times 1.
Why am I striking out here?
Is it still 0 to R?
Yeah, it is. 0 to R. And if you want to be proper in integration by parts, when you have integral limits, you need to put an evaluate 0 to R here if you want to be proper.
That's.
Because this is integrated, right? You need to evaluate it. So that should be there if you want to be proper.
Will the doctors on the test?
I don't know.
Oh, no.
It made sense with what you put in there.
Anyways, so we have negative x e to the negative x minus e to the negative x, 0 to r, is that right? I always just wait till the end to put the evaluate. Just do it all at once.
E to the 0 is 1, right?
Yep.
That means it's favored.
Mm-hmm.
No?
There's not the plug in infinity to find
Here,
out.
little hint, as always, rewrite negative exponents. Negative exponents.
Sure.
Okay, now plug R in.
Something minus.
Negative R over minus. Standard page. Love it. Okay, if I plug infinity in here,
Wait, question. Why is it minus parentheses negative 0 over e to 0 minus 1 over e to 0?
plug 0 in.
Because that's
Oh, you're plugging into the whole thing, huh?
Plug R into the whole thing, minus plug 0 in.
Gross.
Calculus.
Doesn't make any less gross.
It does, actually. It's good for the soul. Pizza's good for the stomach. Calculus is good for the soul.
Pizza time.
I'm down.
Okay, and we get what, this is the one that a lot of people
Infinity.
question.
I don't know, what is e to the infinity?
Infinity over e to the infinity.
What's e to the infinity?
It's a really big number.
It's also infinity, huh?
Does it grow faster than this?
Yes.
No. Maybe.
It's an exponent of infinity.
Zero.
This grows much, much faster than this. You go 1, 2, 3, 4, 5 versus e to the first, e to the second, which is like
Wow.
7, e to the third, which is like 25. See the, okay, so that's 0. Minus 0, 1 over infinity. 0
That's fine.
Plus one.
minus
One.
answer.
Negative one.
It's positive one.
Positive one.
Positive
It's
one.
positive.
Thank you.
I win.
Converges.
At one.
Mine's the lonely number.
Today's a notes taste.
I would argue that 0 is the loneliest number because it doesn't even have itself to entertain.
Ooh,
Mine is some.
Wow.
Nice.
Great, not brutal.
Here's a question for you. Can you ever be alone in a room with another person?
Yes, 100%.
It's a philosophical question. Huh?
It's not
I don't know,
philosophical.
you're
It's
talking
not.
Philosophical if you're dead.
are you talking mentally or like physically? Because physically, no. Mentally, that depends.
Well, alone is relative. Depending, there's no like universal.
Not relative.
Yeah, it is.
Define the word alone.
I don't know, you can be alone at your desk, or you can be alone in the room. I'm alone at my desk, but I'm not alone in the room.
Yeah, but that's not what I asked.
You
I asked,
said,
can you ever be alone in the room with another person?
Yeah, because I'm alone at my desk, but I'm in the room with other people.
My answer stands.
Yeah, but I didn't ask about your desk. I asked about the room. Okay.
is the other person alive or dead?
1 through 60.
Well, if they're dead, is it really a person?
Technically,
Well, that's another argument.
Or was it a
Another
person?
The 1 through 11 on.
Yeah.
Oh, dude, I put 1 through 16. Thank you for catching that.
Yeah, okay, 1 through 16.
I would have sucked. And Montaigne wouldn't have done it anyways.
I wouldn't have done any of it anyways.
He writes it down just to satisfy me.
Dude, you want to see this? Look at how much papers I have for homework that I never did.
Oh, I wasn't kidding when I said what I just said.
I do write it down with the intent of doing it, and then I get home and I'm like, no.
Okay, so that's the first half of limit integrals, improper integrals.
first half?
We're gonna continue this tomorrow. So
So
you're not due until Friday. Your homework is not due until Friday.
Alright.
But you've seen the 3 integration techniques now. Okay.